you have a list of points and you're supposed to find a line of best fit, you can do it a couple ways. One is to use a graphing calculator, but we're not at that point yet. The second way is to plot the points and then look and see what the trend line is, and then choose 2 points on the line and estimate the coordinates of each. Then you would write that equation of the line that passes through the 2 points. So if going to a problem, let's say you have a femur length as a leg bone and what is your height. So the question is, what's the relationship between the two? What's the equation? And you could graph all of these points, but it'd have to be a real detailed graph on graphing paper. Let's just choose 2 points and figure out the equation and then use it to estimate how tall a person is with a femur of 35 centimeters long. Out of convenience sake, what I'm going to do is I'm going to take this point, because 40 is easy to work with, and 50. And first of all, find the slope. So the slope is going to be, again, starting with the larger y and dividing it by the same order of points, so it'd be 50 minus 40. And doing so, you would see that this is going to be 25 over 10, which is the slope of 2.5. Now, you would use your y equals mx plus b equation, and now you know that the slope is equal to 2.5. And again, choose a point that's easy to work with. 170, which is the same point I have here, 40, 170, and this is 40 plus b. And 2.5 times 40 is equal to 100. So this is going to be easy numbers to work with, and therefore b is equal to 70. Therefore, the equation is equal to y equals 2.5x plus 70. The y represents the height, the x represents the femur length. So to figure out the height, you're going to use femur length x, which is 35, y equals 2.5 times 35 plus 70. Plugging that into the calculator, you end up with 157.5, and that's going to be centimeters tall, approximately. So this is a prediction of how tall the person's going to be based on their femur level, based on all of this information. So it's a prediction line, also known as a regression line. But whatever you think of regression, think of prediction.